Earth. One of the best constant angular velocity example is our own living planet Earth. The planet Earth continues to revolve around itself with the center axis passing through it. When the Earth is traveling in a circle at a constant speed, it is experiencing a constant linear acceleration in order to maintain its circular motion. Because it continuously sweeps out a fixed arc length per unit time, the angle of rotation of the object is not affected by this. Uniform circular motion is the term used to describe constant angular velocity in a circle. Fan. This is the most common example we see in our home. When we switched on the fan, we see that the blades of the ceiling fan travel along a circular path with a constant central angle corresponding to their position from the center, thus having constant angular displacement with respect to time. If we increase the speed of the fan by one level, then it will continue to perform in a circular path with constant angular velocity. Gramophone. A gramophone, like any other mechanical device, operates on the concept of constant angular velocity. The needle of the gramophone travels over the surface of the record disc, covering an equal angular distance in a given interval of time, and as a result, the relationship between angular displacement and that of a given unit of time is constant. And hence it is the example of constant angular velocity. Tire. In the old-fashioned automation technology, vehicle tires used to be found in varying speeds depending on the acceleration paddle. And today, as a result of the most recent advancements in technology, a new invention has been introduced, the speed lock function. This feature allows the driver to lock the speed wherever required, which enables the vehicle to run continuously with the constant speed as a result of constant angular velocity achieved from the tire of the vehicle. As long as the driver does not disable the feature of speed lock, tire of the vehicle will continue to achieve the constant angular velocity. Wall clock. Time is represented by the hands of a clock traveling along a circular route with a constant central angle equal to their distance from the center, and therefore with constant angular displacement with respect to time. The time it takes for each of the three hands, hour, minute, and second, to complete one rotation is different, even though they all move with the same constant angular velocity. To travel an angle of theta equals 90 time taken by three hands respectively will be as follows. 1 seconds hand will take 15 seconds. 2 minutes hand will take 15 minutes, 900 seconds. 3 hour hand will take 3 hours, 180 minutes / 10,800 seconds. Satellite. A satellite orbiting the planet moves along a circular route as a result of the gravitational pull of the Earth and the circular motion of the satellite. We know that the satellite will never cease orbiting or will orbit at various speeds. This happens as a result of the constant angular velocity. In a given unit of time, a satellite travels an equal angular distance or sweeps an equal area of an arc, and continues to do so, resulting in a constant angular velocity for the satellite. Cutting blade. In the industrial sector, we frequently see the usage of an electric cutting blade for cutting heavy and thick items such as marbles. This heavy electronic equipment always comes with the ability to adjust the power levels, which are used to adjust the cutting strength of the blade in relation to the size of the object being cut through. When a certain power level is selected, the cutting blade continues to revolve at a constant speed, which is nothing more than a phenomenon of continuous angular velocity that is utilized to cut the items. Grinder. Every kitchen contains a grinder, which is the most generally accessible and most widely used electrical equipment. Because the blades of the grinder revolve in a circular manner, they are able to grind the material that is contained inside it. During the time that the grinder's blade is moving, it covers an equal area in equal intervals of time, resulting in an angular velocity that remains constant throughout the operation. This speed remains constant until the power level is changed. And, after the level is changed, the blades of the grinder operate at a constant angular velocity instead of the prior velocity at which they performed. Fine chopping of the material depends on the level of constant angular velocity that occurs as a result of the application of power. FAQs. Q. What is the meaning of angular velocity? ANS, angular velocity, is an important component in an object's rotational motion. The angular velocity of an item or particle is the speed at which it rotates about a center or a specified location in a certain time period. Additionally, it is referred to as rotational velocity. Angle per unit time or radians per second, rad/s, are used to express angular velocity. And the rate of change in angular velocity is called angular acceleration. Q. What is constant angular velocity? ANS, the axis around which it revolves and the rate at which it rotates are both constant. An item, S, or particle, S angular velocity is the rate at which it revolves about a center or a defined place in a given time period. And constant means not changing or remains the same. So the constant angular velocity implies neither its rate of rotation and nor the axis around which it revolves are changing. Q. What is the value of the angular velocity of the Earth? ANS, it can be calculated by using the formula of angular velocity. The angular velocity of the Earth equals to radians/time of the day in seconds equals to radians/84,600 s equals 7.2510 radians/s. Therefore, the angular velocity of the Earth is 7.2510 radians/s. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.